Hello, everyone, and welcome back. This is Mike, and we're going to continue our next session around storage capacity metrics and a deeper dive into how we leverage those metrics in the future for reporting. All right, so let's go to the next slide. Let's talk about usable capacity. So, usable capacity is the metric that is derived from raw capacity when you create a RAID group. Now, a RAID group is for data redundancy, for improved performance, fault tolerance, capacity, utilization, hot swapping. It basically allows you to manage your storage on the back end more efficiently and protect the consumers of the data more efficiently as well. So when we apply that RAID group, it basically will create a uh, a component inside of your storage system called a pool or aggregate, right? So we apply that RAID group of physical disks to the storage pool or aggregate, and then we're able to provision that capacity to end users to some degree. Okay. Now, there are other forms of usable capacity based on how we configure the storage environment. So, the next one that I want to talk about is effective capacity. So, this is the result of using or applying data reduction ratios. So, what's data reduction ratios? So, basically, data reduction ratios are what's calculated based on how deduplication, compression, or compaction is applied to the storage pool or aggregate. All right, those are efficiency technologies that allow us to reduce storage consumption or waste by actually applying that at the pool layer, even the volume layer. We have that capability at both for both, and it does definitely show a significant savings from allocated capacity, right? So it's important to really understand that out of the gate because when we develop reports to show value to our customers, they really want to know what these numbers are and how they're applied and how much they're actually saving in capacity. Right? And then we can associate costs with that. So there is a lot of value to be derived from invoking these storage efficiency technologies. Right? So configured capacity is now the next step in the process, which is also known as provision capacity. It's either thick or thin that you would assign to physical devices, right? Now they could be, ESX, they could be just standalone physical servers, they could be other things in the environment that require capacity to some degree, gateway servers, things of that nature, and the type of storage efficiency that we would apply at that layer would be whether it's thin provisioned or thick provision, right? So that's important to know. And thin provisioning is the efficiency technology that allows the administrator to provision more capacity than is physically available. That's an important point. And build reports and run reports against the storage environment. We're looking to see how efficient and how well managed that environment is based on these storage efficiency technologies. Thin provisioning is a big risk. You're basically, you know, provisioning more capacity logically than is available physically in the environment and allows you to get stretch more use out of your storage system and basically cut back on expenses and costs for purchasing new equipment, right? So we want to definitely take advantage of all these technologies to get value out of our storage environment. But we really need to track it in DII so we don't run into any problems, right? So we have reports and we can build reports around these technologies to show value, right? ROI right out of the gate. Okay, use capacity. This one is a little bit more fuzzy at times because depending on the storage technology you're working with, use capacity can mean different things. So it's basically capacity that is written to the storage pool or aggregate, right? So that when we look at it at the highest level, that would be how I would represent use capacity in a report that's associated with a NetApp device or other types of storage vendor devices, right? So when we look at it, the physical used is the highest layer. The next layer is logical capacity. Logical capacity includes the dedupe and compression, right? So when we look at physical use, we add dedupe and compression values. That gives us logical capacity. Now we can calculate a data reduction ratio that will be physical used plus dedupe plus compression divided by physical use. A lot of people want this. They want to show what their efficiency is. Their data reduction ratio shows how efficient their storage environment is being utilized, all right, and managed. So data reduction ratios are calculated using these different metrics. All right. Next up is when we look at the current metrics that are available, we start deep diving into the schema. Now, I'm not going to get too much in the weeds with this. I just want you to look at it at a high level. So when you go into our inventory database or data mart, you'll see storage pool associated with the inventory database. And within storage pool are these popular metrics, right? So this is basically how we're showing the data in a raw format, right? So when I look at my storage environment and I want to apply these metrics in a report, they're all going to default, as I mentioned earlier, to megabytes. We have to convert it to what the customer wants from a unit perspective. So usually that's going to be in tebibytes or gigabytes. And I've already shown you the mathematics as to how to do that in your reporting. So in the data mart part of the data warehouse, that's already done for you. You have the capability to show it in Gibby, Tebi, and MIBI. Okay, so when you drag and drop reports, you will see those different units of measurement available, and you can just drag it over to the canvas. In SQL, however, and again, my best practice for building reports will be SQL. You get way more value out of that than you do the drag and drop. Even though the drag and drop is good for some purposes, it's not good for all of them. So we need to have knowledge of both. So in the data warehouse, when I look at my schema, I'm going to see these field names, and in the again, when you look at the schema, it will have a definition associated with it, and it will explain exactly what they mean. Right. So when you look at total allocated capacity at the storage pool level, it is allocated for storage pools that's reported by the storage array. So again, when I create my RAID groups and assign those physical disks to that RAID group and then allocate it to the storage pool, that's what total allocated capacity represents, right? So and again, this is the inventory perspective. So it's current data only, right? So when you look at storage pool from an inventory perspective, these are the fields you're going to see. Now, if I go into the capacity databases, which are time series, right? They have historical data. Those fields are going to change based on the fact that they are time series related. All right. Similar type of result, but again, you're looking at it over a specific time. All right. So inventory is current data, and there are other data marts databases, like capacity and performance, that will show it over time. So get used to these metrics, understand these metrics, and I'm going to continue to reiterate, how these are used and what they're used for. And when we start building out SQL queries and we do a little drag and drop reporting, it's going to make a lot more sense. But I want you to understand this is what the schema will look like when you're actually leveraging the metrics. No attributes here. These are just metrics. Attributes are names of things. You'll see that when we get down to that layer, okay? So next up, we have volume level metrics, and this is just capacity, really. Again, I'm just focused on storage capacity, nothing else right now. So volumes is SAN or block storage, and you're going to see 4 capacity metrics associated with block storage. Capacity is the volume usable, consumed. Basically, it's the kind of like used, but not really. Written capacity is what written. Not all vendors support written capacity at this level. Some vendors will not. This will basically just be null. There'll be nothing in the column. And then, of course, raw capacity is available as well. So when you talk about consumed capacity and you're looking at block storage, I would use that metric in lieu of used capacity. Okay? So consumed capacity includes physical space used by LUN data, compression and dedupe, snapshot reserve and space used by snapshots, volume metadata overhead, fractional reserve, and any overwrite reserve. So that is what consumed consists of from a block perspective. Okay? And again, best practices when I write reports around block capacity, I typically use consumed as used capacity. All right? So that's what you'll see in future reporting. Next up is internal volume. A little bit different technology here. So it's similar to how the pool was structured. You see similar metrics, total allocated, total used, data allocated, data used, and they all have different properties based on what you're trying to accomplish. All right, data allocated, data used do not include snapshots. Total used and total allocated, total used do contain snapshot data. And then you have a snapshot allocated, snapshot used. Raw to usable ratio is how I calculate raw capacity based on total allocated. So I can derive raw capacity from an internal volume by applying that percentage to total allocated. And that'll give me raw. We have other allocated, total clone, and then we have our compression ratios and savings. Okay, we also have our dedupe ratio and savings up the top here, not in any specific order. Okay, so again, you're getting a quick and dirty look at the schema that is published by NetApp for DII. Okay, so we will do more and more of this as we proceed through the course and learn more about the reporting environment. Okay, so this is now a time series look at the storage and storage pool capacity fact, a very popular and important table in the data warehouse. All right. So when you see storage and storage pool capacity fact, you'll see these type of metrics. You'll have capacity, raw capacity, used raw, snapshot used, unconfigured. You'll see spare raw, you'll see failed raw, volume, unused volume, volume consumed, mapped and masked, internal volume allocated, internal volume used, internal volume consumed, and then your storage efficiency, dedupe ratios, compression, and compaction. Right, so that's what's available in the storage and storage pool capacity fact. There's also a storage and storage pool future fact that allows me to do forecasting. Right, so I combine those two tables together in a union, and when I create that union, and I'll talk about this more, and we'll demo it in future sessions, and you'll understand how to build out reports that will show capacity forecasting over a time period. So that is really cool stuff. So these are the metrics that you would see in the storage and storage pool capacity fact. And anytime you see the word fact, it denotes time series data. All right, a fact table is a time series data table in the data warehouse. Very important. All right, so this is at the pool and aggregate level, time series specific, storage and storage pool capacity fact. That one you will use quite often. Okay. Next up is storage performance. Now, performance takes on a life of its own, right? So capacity is pretty straightforward. Performance metrics vary considerably, and there are a lot more data points, especially when you're using the hourly fact tables that are associated with performance, right? So it's important to understand what's available at first at a high level. I look at storage metrics. I'm just going to kind of put these on the screen real quick. Storage performance metrics at the node level, you have CPU utilization, node for FA ports for in Symmetrics and PowerMax worlds are FA port utilization, not CPU. Most metrics are total read and write. We have total read write IOPS, total read write throughput, total read write response time. They're different metrics. There's total read and write for each one of these categories. Okay. When you have CPU utilization, you'll have average and max. You can have max of average and max of max. That's the best practice, and I'll talk about that momentarily. You have response time, which is latency in milliseconds. I/O density is IOPS per terabytes, basically how we calculate service levels. And then we have disk utilization percent, which is basically disk busy. All right. And there's a lot of subsets to disk utilization that are published. I'm not going to talk about that now, but when we get into that part of the reporting, I'll definitely break it down for you. Next up is the compute metrics. So for mostly the hypervisor world and VMware or even some cloud resources. So when you're looking at Amazon EC2 instances, we don't see all of it, but most of those metrics are available. All right, so for compute metrics in the VMware world, you have CPU utilization, both average and max, memory utilization, average and max, and that's for the hypervisor and the virtual guest. You have IOPS, total read and write, throughput, total read and write, Same for response time, which is latency. You have IP transmit, IP throughput. There are a few other metrics, so we don't use that regularly. When I bring up the schema down the road, you'll see them. But this is basically what we utilize when we build out reports for performance. And depending on what use case we're trying to address, will dictate how they are applied in a report. I will definitely show you multiple use cases when we get to that point of the course. Okay. Oh, swap rate. There's another one. I missed one. Sorry about that. Swap rate is one other one, but there are quite a few smaller metrics, and I'm going to correlate the data warehouse with the data lake too. So there's other things we're going to talk about, so you can see the differences and how it stacks up. All right, so that's basically what we have to work with in the data warehouse for performance metrics. This is the schema for storage node. So when you look at the hourly performance metrics, that's 24 metrics per day for 14 days. That's a lot of data points. Definitely gives the end users a lot to go by and make decisions on. We can also forecast that with linear regression. However, it's got to be programmed. It's not out of the box. So basically, there are no regression models for performance. But I have built reports that will leverage linear regression algorithms in SQL to actually use performance forecasting, which is quite interesting. All right. It's a little bit more of a moving target, of course, not like storage capacity, but it definitely can help you predict where a storage system is going and how much performance utilization or what their used performance would be, okay, against their budget. So here are the metrics that you would see in the schema, okay, and these are the actual field names, okay. And again, I'm not going to go through them in detail, but this is what you would see in the schema, and it would basically have a description of what they mean. And I have actually built out advanced documentation for these metrics and how they're applied, both from the web UI perspective and data warehouse. So we do have a thorough, what do you call it, descriptor associated with these metrics, right? And that's available as well. But yeah, these are, and they're pretty much industry standard. Everybody's using the same things, but they do have different use cases. All right, so keep that in mind when um, we're building out reports. It depends on what the customer wants to solve. What use case are they trying to solve, and what are we going to use to address that problem? So we will do more of this again when we get to the Cognos environment. We build out actual reports. I will show you how to leverage these metrics and what kind of use cases they will apply to. All right. One thing I wanted to mention, that node specific performance is front end. I did mention it earlier in this session. It's protocol derived metrics. They're front end metrics. They're not back end or volume level metrics. They're front end or disk level metrics. No. This is from the controller's perspective, right? So these metrics are derived from that layer. And again, as I mentioned earlier, PowerMax symmetrics arrays will show performance at the FA port level. Okay. And some metrics for vendors like Data Domain and Isilon, some metrics may not be available. They are represented in the support matrix. You can actually see what's published and what we should expect from a specific vendor. And if the metric is included in the list, then we should definitely get data from it. Okay, so we can review that. We'll review that in a subsequent session. I want you to understand the support matrix and actually how it applies. Okay, from an internal volume daily, hourly performance fact, I use this quite a bit. Similar types of metrics, as you can see. All right, the IO density piece is used for storage and design workshops and also for calculating service levels. And we have many reports that actually leverage that and provide great ROI and immediate value for our customers. Okay, so we'll talk about this in detail, but this is what you would see in the schema. Gives you the description, and this is a very slimmed down description, of course. But again, these are industry standard metrics. You can easily Google these; they'll all come up. Most vendors support them. And if you want, when we talk about it in reporting, I'll get into the details and we'll look at some of those definitions when we get to that point. Again, we're just kind of reviewing the schema and what it looks like and what's available. This is a disk daily and hourly performance fact schema. These are the metrics that you would see associated with disks. There's no latency associated with disks. You definitely have utilization that's just busy, and the write-ops and IOPS and throughput are available, but no latency at the disk level. Okay. VM's pretty robust. It has a lot of neat metrics, both for your hypervisor, ESX server, and the virtual guests. We have some great reports that show utilization based on what's provisioned to the virtual guests and where they stand from a subscription perspective, and then the performance associated with utilization around CPU and memory and IOPS and latency. All right, so I have reports that can show you the entire VM infrastructure, migration reports that show, what's, where you can add new hypervisors or consolidate hypervisors and so forth. So there's many really powerful reports that are available, and we can create our own depending on what your use case is. Right? So good stuff. But again, we'll get into it in a deeper dive when we get to that level of reporting. Now, one thing I want to talk about is data aggregation. It's not an aggregate like a storage pool or NetApp aggregate. It's aggregated data. It's like summing, averaging, things of that nature, right? So when you look at how we're pulling performance metrics, all right, a storage system typically is configured to collect data every 5 minutes in DII. So if I look at a NetApp cluster, a NetApp node, NetApp storage device, it's pulling performance data every 5 minutes. So that's 12 data points per hour. Well, it looks at it like this. It's going to look at it from, that window of time, that 1 hour window of time, before it sends it over to the data warehouse. It's going to do two things. It's going to average, max, min, last, and sum. So it's basically going to provide those values at that level of aggregation. So when I get over to the data warehouse, I have max and I have average. Okay. In the DII, 3 hour time window, this is what you would see in the DII web UI piece, right? But when you get to the data warehouse, we are taking those metrics and getting the max of the hour and the average of the hour, right? We do get a minimum, we do get a last, we do get a sum. However, you're only going to see on the data warehouse side the max and average. I just wanted to make a note because there's a lot going on during that hour, and you'll have different levels of performance based on what metric that you're trying to pull. Okay, and I want you to understand that what you see in the web UI is not always what you're going to see in the data warehouse. Okay, because of the way it's aggregated and because of the different time intervals that we're dealing with. We're getting hourly data or daily data in the data warehouse. In the web UI, it's almost near real time. All right, when we're collecting that data, it immediately is updating the database and showing that data in near real time. Okay, and then as you look at your intervals in the web UI, you have the capability to show that over longer intervals, right? Up to 30 days. And that's when this type of aggregation methodology is applied. But in the data warehouse, like I said, all you're going to get is the max of max and the max of average. So when you look at the web UI, okay, and you calculate your metrics, so I'm looking at latency, you will actually be seeing max of max and max of average. So when I go to the data warehouse, I want to apply those aggregation methodologies to my metrics. Max of average, max of max. Keep that in mind when we get into programming and creating SQL queries. That's exactly what you want to do. So you want to vet out your reports so they look exactly like what's in the web UI. And we're definitely going to do that on a regular basis. Okay? So that's where I'm going to stop. This is basically the high level 10,000 foot view of the data warehouse, but it does help in understanding, how it's structured, what we're going to do with it in the future, and what the best practices are around building reports and managing your environment. So I hope this was helpful. We'll definitely start up the next process with a little deeper dive around aggregation at the web UI level, and also get into the Cognos environment so you get a good overview of the drag and drop reporting environment. So that's it for today, and look forward to seeing you in the next session. Hello, everyone. This is Mike again. Let's continue on our discussion around capacity. The big focus is how data is rolled up and aggregated, okay, between the web UI and the data warehouse, but also how the customer will see their native tools and the disparities that are common between those three platforms. So there is a reason for it, and we're going to discuss that with a view of the web UI and looking at the collection engine first, and then we'll get over to the data warehouse eventually to see how that works and how data is aggregated at that level. So first things first, I want to talk about collectors. So we're on the sandbox tenant in the NetApp environment. It's just a lab, so it just has a lot of lab devices. Not everything works, of course. But I wanted to point out, basically how the data is collected and how a specific collector is configured in order to do that. So we're going to edit just a VMware collector here, and then click on Advanced Configuration. I just wanted to point out that when you look at performance, by default, you'll see the performance poll interval. It's in seconds increments. That's 5 minutes, of course, and not all collectors are equal, right? For instance, the actual inventory polling is every 20 minutes, but performance is every 5 minutes, and that'll give you those 12 data points per hour. Now, the customer can change this, and there are best practices around that, what the recommended setting is for each data collector. But just remember that when you look at storage systems versus compute, they are slightly different and they do collect different things. And the computer is a little less robust than a storage system because of the storage hierarchy that I talked about and all the things in between. Okay, nodes, aggregates, pools, volumes, block volumes, queue trees, quotas, physical disks. All those layers in the storage hierarchy have metrics, right? And the collectors that we're adding to DII actually go out and get all that stuff, right? So it's a lot of activity and it's a lot of work to pull that in, and process it and put it in the right buckets within our product. So keep that in mind that when you change these intervals, it will impact, how frequently the data is collected, but how much you're storing inside the database, which makes a difference. So right now, your VMware collectors are defaulting to 5-minute intervals for performance. For NetApp gear, I'm going to go into a NetApp ONTAP REST client and go to advanced, and you can see your OData polling or performance poll is 900 seconds, which is 15 minutes, and the inventory poll is 60 minutes. Okay, so it's quite different. And the reason for this is, the best practices are what they are, but, out of the gate, when you add these collectors by default, these are the numbers you're going to get. Oftentimes, they're not changed. So when you run reports and you look at that hourly data collection for storage systems by default, it's not going to be 5 minutes usually, it'll be 15 minutes. But that can be changed. Customer has the capability to change that. Right, so whatever the interval they want, they're going to do. They're going to add. Okay, the more, like I said, the tighter the interval, the more data is stored, and the longer it may take to get out of the product in different ways. So be aware of that. That's very, very critical. These polling intervals are key to understanding, how we're presenting this from a web UI perspective and also from a data warehouse perspective, and how it can be different from the native tools. A lot of times the native tools will collect this data, every, maybe 10 seconds or even tighter than that. So, that does make a difference as to how we roll it up and how it would be averaged over an hour, how you'd see the peak maximums over the hour. That definitely changes based on just normal timing factors, right? So that oftentimes that's where we see the disparities. It's just the collection intervals do not line up at all, right? So let's go take a look at what that is in our metric queries. So I'm just going to go to new metric query, and I'm going to type in storage, okay? And when you look at storage, it's just going to kind of pull up the default inventory specific data, but also raw capacity, and then also total IOPS. So this is an aggregation of IOPS from the basically the logical volume level, And if it says disk IOPS, then it's aggregated from disk. But if it says total IOPS, that infers that it is logical in nature. Okay, so there are fields that you'll see in the web UI that will say disk IOPS versus just IOPS or total IOPS. All right, keep that in the back of your mind. They do come from different places. Again, that storage hierarchy makes a difference. So here, this is an aggregation of IOPS. And I'm going to sort it in descending order. And you're going to see that these fields can be manipulated, all right? Similar to what we do in reporting, but not the same. It's actually more robust here to change the aggregation methodology by basically your group and your time. So I'm going to change time to maximum, okay? So that's an aggregation. You can see that the maximum for this storage system is 20,000 plus IOs for the last 24 hours. I can tighten up those intervals to 15 minutes and it does change significantly. Okay, so intervals are everything. So you can do 15 minutes, 30 minutes, 60 minutes, and then hourly metrics and then daily metrics. Okay, so we go up to 30 days. We can go back 90 days, but only show 30-day windows. Okay, that's how this works. And we'll give you a pretty good overview of how your storage system is performing and how what the capacity utilization looks like. Storage systems do not show used or usable capacity. Storage pools do. All right. So when you remember, I talked about in the previous sessions that when you look at metrics, storage systems will only show raw capacity. Along with raw, they'll show spare disk capacity, failed disks, and anything that is a raw. Even if it's a submetric, it's associated with raw capacity. Okay, so this is what I mean by aggregation. When you see these different drop-down boxes, and you see group by and then aggregation time, and we're grouping by storage, so that's why that's by default. It's just averaging by default. But then the time aggregation, the last 15 minutes, I'm getting the maximum, or I can get the average. All right, and it does change significantly based on what you select. So if you do the last 24 hours, and I look at the average for Jamaica here, okay, and then change that to maximum, you can see a huge difference. Okay, there you go. It's a 5,000 IO difference in 24 hours from the peak to the average. So again, not rocket science. It's just basically how the data is appearing in these tools. Okay. And by default, they're averages. But if you want to manipulate it, you do have the capability in the web UI to change the aggregation a little bit more granular than the data warehouse. You have average, last, maximum, minimum, sum, change, and change ratio. And that'll definitely impact what you see from a reporting perspective in the web UI. Okay, now when you go to the data warehouse, all I have is that makes sense is sum, average, and maximum. Okay, I can use minimum if I want, but it really doesn't, I look at the use cases and I really never had an ask for minimum capacity other than when I'm showing growth over time. That's about it. But for the most part, those are the three aggregation levels we use in the data warehouse. And again, I just wanted to show you how that compares, okay? And when you look at capacity, you can change the unit display. You do that by changing the lower, leave the base at gigabytes, and then change it to whatever you want, like tebibytes, okay? So down here, I should see my TIB right here. So we'll automatically change that capacity. Same functionality in the data warehouse, okay? But you have to use that base 2 approach, dividing the capacity by 1024. If it's base 10, if it's storage grid, you're dividing the capacity by 1024, but also multiplying by that multiplier I showed you, 1.07 and change, right? So keep that in the back of your mind when you are, vetting out reporting, vetting out the data collected from the customer's storage system and how it's presented. Make sure they understand when we pull it in here, there are different methodologies for aggregation. Very critical. And when you're vetting out your reports, make sure you're comparing the aggregation levels correctly. All right. If you're using max of average and max of max, then you should be fine. Everything should match when you're looking at it from a landing page perspective. So if I'm looking at charts, I go here to the extended views and I look at the charts that are associated with this. I want to make sure that what I see here These values right here at this point in time matches what I see in the reports. Okay, and that's how we vet it out and ensure accuracy. And anytime I build out an artifact in the data warehouse, I always come back here and check that my numbers are correct and they match the numbers in the web UI. All right, that way I know it's accurate. I know the information is consistent and the customer can consume it with confidence. All right, so that's what I wanted to do with this session. This is a little shorter session of just understanding that native tools will never match the web UI only because the intervals are different, okay? Mostly. And the way they collect data from the native tools is pretty raw, all right? There's nothing added to it when it's processed into a database or data warehouse, okay? That is a different thing. So we discussed how that happens, what we do with it, and how we average the data, maximize the data, or aggregate the data to some degree will create that disparity. Okay, so that's all I wanted to talk about, just data aggregation. And now we're going to go to the next session and talk about the basics of Cognos and drag and drop reporting. Thanks for joining. Thanks for listening in, and we'll see you in the next session.